Hello, let's continue our Sudoku adventure with Can't Find My Place by Toir. So this is a companion puzzle to yesterday's. I wanted that to be a surprise though. So we have normal 6x6 Sudoku rules, which means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have zipper lines in the grid. So the way zipper lines work, it's a little bit different if they're odd or even in length. The length is just the count of the cells that it occupies. So this is length 5, right? So that's odd. So in odd ones, you take the center cell, say that ends up a 5, and all the digits equidistant from the center sum to whatever that middle digit is. So maybe 2, 3 here, maybe 3, 2 here, or we could do like a 1, 4 somewhere. The point is these add to 5 and these add to 5 because there's a 5 here. If there was a 4 here, they'd add to 4. If there was a 6 here, they'd add to 6. All right. For even length lines, we don't have that center digit, so it just means that these sum to the same as these. These sum to the same as these. So if this was 2, 3, let's do a bigger number. If this was 3, 5, that would sum to 8. This could then be 2, 6. So these sum to 8 and these sum to 8. We don't know what the sum is, though. We got to figure it out in both cases. Additionally, each line is an anti-reference line. That's why we have these little 2-cell zipper lines, quote-unquote zipper lines. They don't do anything in terms of the sum, because whatever they sum to is what they sum to, right? But they do work for the anti-reference lines. So a line with length n must not include the digit n. So this line is length 3. It must not have a 3 on it. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. How should we get started? Well, let's think about this 5 length line. It can't have a 5 on it. So we have 2 distinct, well, we don't, I mean, this is at least 3. Naively, this is 3, 4, or 6, because it can't have a 5 on it. If this was a 3, we'd have a 1, 2 pair here and a 1, 2 pair here. And honestly, I don't see a problem with that immediately. This doesn't have a 3 on it. Seems okay. No 2 here, no 2 here. This is harder than reference lines, I think. So what's our break in here? How do we get started? If this was a 6, we couldn't use the 5, so it would be 2, 4, and 2, 4. Or 3 plus 3. Can't discount that. This doesn't have a 4 on it? Okay. This does not have a 4 on it, so where's 4 in the box? It's up here. That means this is not a 4. It's also not a 3, because we can't involve a 4 in a sum to 3. So this actually is a 6. We get our digit. The 4 is definitely joined by a 2. In fact, these are from 2, 3, 4, and these are from, yeah, they're both from 2, 3, 4, because it's either going to be 2 plus 4 or 3 plus 3. We can't be 1 plus 5 because we're not allowed to put 5 on this line. This can't be a 6 anymore, which means this can't be a 5. So the 5 is here or here. We also can't involve a 2 in here because the 2's pointing. I'm not sure what to do with that yet. Okay, so these 2 add to these 2. We know they involve a 1 somehow. So the biggest we're going to sum to is 7. I'm not sure what to do with that. There's a 6 down here. Okay, so this line has a 1, a 5, and a 6 on it because they're not here. Here's something we can talk about. The sum of these 4 digits is even because it's this sum equals this sum. And if you have the same sum twice, that's an even number by definition. And x plus x is 2x, and that's even because it's divisible by 2. You can divide it by 2 and get x back. Anyway, I'm sure I didn't have to explain that. So this is even. This whole sum of this is even. Which means, and we know the whole box sums to 21, which is odd. So how do you, if we have an even, we need to add an odd to that to get it to be odd. So these 2 are sum to odd digits, but we know they include a 4. So if they include a 4 and need to be odd, they need to include an odd digit, which means this is a 3, 4 pair. If this is a 3, 4 pair, the 4 is going to go with a 2, and the 3 is going to go with another 3, making this a 2, 3 pair. That's cool. I like that. And that makes this 1, 2, 5, 6. That's not a 6. So we're going to end up with a sum of 7. And it's going to be 1, 6, and 2, 5. Which we kind of know because these add to 7. And 21 minus 7 is 14. So these are going to add to 7 as well. But I don't know what I can do with that at the moment. We know there's a 4 down here because of the 4 is up here. So it's got to be down here. Joined by this 1, 2, 5. We know there's always a 3 down here. I don't think I want to mark that right now. Okay, I don't think I can do more with this. Is there something similar I can do elsewhere? Right, this doesn't have a 2 on it, so we're going to need a 2 here or here. And the 2, 3 pair says no 2 here. This doesn't have a 2 on it because of the anti-reference. So there's a 2 in one of these two. If we wanted this to be a 2, this would have to be 1 plus 1. And I'm not... We'll put a 1 here, but I'm not immediately seeing a problem with that. 1 plus 1 is 2. Or this would be a 2, and this has quite a bit of freedom, 3 through 6. Okay, I'm not sure I can do much with that. This does not have a 3 on it. I should remember that. So one option is 2 with 1 plus 1. The other option is this is a 2. And so we could do 2 plus 1 is 3, but we can't because it's a length 3 line. We could go 2 plus 2 is 4. That seems reasonable, as far as I can tell. We could have 2 plus... Can't do 2 plus 3. Can't do 2 plus 4. We could do 2 plus 5 is 7. No, we can't because 7 doesn't exist. So this is literally all we get. That's crazy. We're either 1 plus 1 is 2, or we're 2 plus 2 is 4. These are always the same digit as each other. And that ends up down here. I'm going to mark that. In fact, if they're 2s, it goes here. If they're 1s, it goes here. So 5 isn't one of these two. This is just 1, 2, 5, for what it's worth. Hold on. Oh, never mind. We're fine. I got confused by something. All right. We're excluding 2 from these two cells for some reason. Trying to think about why we would do that. Like, what's that do for me? Okay, we know 2 doesn't go here. Maybe I should fill these as 1, 4, 5. Oh. Is that? Or... No, I think that's fine. I was thinking maybe either the 2, 1, 1 or the 4, 2, 2 broke this 1, 4, 5, but I don't think it does. Okay, well, we're certainly not adding to 1, so the 1 doesn't go there. So we're adding to 4 or 5 between these two cells. If we add to 4, this has to be a 1 with a 3 here. That's the only option, because 4 and 5 are too big. If we add to 5, 5 is still too big for this, by the way. If we add to 5, then we have to be 4 plus 1. That's it. That's all we get. Or we could be 1 plus 4. Oh, no, we can't be. No, 5. Yeah, 5 would be 1 plus 4. That's true. I'm getting confused. Sorry, all this case checking. I feel like maybe there's a more elegant way to think about this, but I haven't found it. There's not a 3 here. The 3 goes here. Right. Okay. So importantly, 3 is excluded from these two cells. So where does 3 go in this column? Up here, which means this can't be a 3. It's claimed by this column. So if this is never a 3, how are we adding to 4? And the answer is we can't, because we can't do 2 plus 2. We can't do 1 plus 3. So this is a 5. That's not really what I wanted it to be. But that does make this a 1-4 pair. This sees the 1-4 pair. Either this is 1 or this is 1, and that's going to see here. So this can't be 1. So that makes this 2 plus 2. That makes that a 2. We don't need the colors. That adds to 4. That makes that 1 and 4. We get the 3 and the 4 here. These aren't 2s. That places the 4 here. That's a 3. That's a 4. This is a 1-5 pair. 5 seems big for this. But 516 does seem possible, so I don't think I can exclude it. Right, 2 is placed in this box because these aren't 2 because the anti-reference line. So that's 2, that's 3. This is not a 2. We get a 3 in the corner, deep dooting on ours. Okay, so this is 3, 6. That's 6, that's 3. This is a 1. That's not a 1. This is 5, 6. This is 1, 5. This is, yeah, there's no 2, so this can't be 1 plus 1. Okay, these two are different, right? Because they can't be 1 plus 1 equals 2. There's a 2 here. And it can't be 5 plus 5 equals 10, because 10 is way too big. So they are a 1-5 pair adding to 6. And this is the leftover 3. Also deep tooting. All right. We need a 4 somewhere here. Actually, the 4 is placed here. So this is only 5, 6. Which would be 4 plus 1 or 4 plus 2, but it can't be 4 plus 1. So 4 plus 2 is 6. All right, 1-5 pair places 6 and 2. We're going to be doing 2 plus 5 and 6 plus 1 for the zipper to work. That's 5 and 6. That's 1 and 5. Remember, that's 5 plus 1 is 6. This is a 3, and then these two digits are 1, 5, and we're done. All right, took me a bit. There were definitely some intricacies there. I think the key break-in was box 3. That these couldn't be 4, so that forced a 4 up here. And then in addition to that, these were even in sum, forcing this to be an odd sum, which forced this to be 3, 4. That was in this to be 6. That was really interesting. Yeah, I liked that. I think it forced this to be 6. Pretty sure it did. Yeah, because of the 4 on it. Pretty sure that's what did it. Anyway. What was kind of the next breakthrough? It was the fact that we had this 2-3 pair, forcing this to be a 2-1 here. I think that really restricted this. This was surprisingly restricted. So yeah, cool. Just had to think about the correct zipper lines as we went. Let me know how you did. And of course, if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.